The broadcast is now starting. All attendees are in listen-only mode.
Hello, thanks for joining us today for this webinar on building HVAC system readiness for reopening. We're thrilled to have two featured speakers today from McKinstry, Geremy Wolff and Sycuro, to give you a commissioning provider's perspective on reopening. So again, thanks for joining. The webinar will be recorded and slides posted on the Better Buildings website. And thanks to Better Buildings for hosting and publicizing this webinar. We have a great crowd today. I think almost 300 people signed up. So get your questions into me early. I'm Hannah Kramer from Lawrence Berkeley National Lab. I'll be sorting through those questions and asking Geremy and Jesse towards the end of their presentation and trying to group questions if I need to. So get your questions in early. Next slide, please. Great. So we're going to start off with just this brief reference to ASHRAE guidance. You may have already seen all the great resources on the ASHRAE's website about building operations in pandemic mode. There's some quite detailed documents and slide decks on their website. The links are here. And going through these documents, it's clear you need systems that are ready to operate in different ways than pre-COVID. So today's webinar goal, we want to spend today discussing how to get ready, how to make sure the systems are capable of implementing these new strategies. And Geremy and Jesse will be discussing what needs to be evaluated when there's not time or budget for a full commissioning process relative to these new strategies for pandemic operations. Next slide, please. So there's three basic phases that will be covered in today's webinar. Like I mentioned before, there's this system evaluation, making sure you're ready to reopen, that you know how your systems are operating to be able to manage key strategies, selection of those operational strategies. And Geremy and Jesse are going to touch upon those today. We're not going to go in super great depth, just in the interest of time. And then also not forgetting about the ongoing monitoring piece to make sure things are operating over time in a safe manner when people are in the building. I'll also note that Lawrence Berkeley Lab has many resources on the use of energy management and information systems, including fault detection and diagnostic tools, which are really helpful during this ongoing monitoring time period and this challenging time for building operations. We talked to a lot of people that say that they're happy that they have their EMIS in place, they're able to monitor remotely and at a granular level to automatically detect when their operations are outside of what they want them to be, and give them more confidence that their systems are continuing to operate properly. So we're going to touch upon all these three sections, and then we'll have a Q&A. And at the end, I'll wrap up with some research that LBNL and other national labs are doing to try to, get some answers where there's big research gaps and understanding with this new virus, how it relates and is transmitted in building HVAC systems. There's a lot of questions on that. There's no definitive answers. We're going to talk about just precautions today, and hopefully, this new research will fill in some of those gaps as well. Next slide. So we're going to start off today with a poll, just to get a sense of who we have on the call. I know we have a lot of owners on the call. We have commissioning providers that are supporting owners in their reopening plans. So if you can think about either for your buildings or for the building owners you're supporting, how far along are you in the process of reopening? Here's the poll question. Please select one that kind of best fits your situation for the majority of your buildings or clients. And we'll just wait a few seconds here for those numbers to come in. Okay, we have the results. it's pretty even, except we do have people, getting ready to reopen. And, so those that are early in their planning and system assessment, you'll find a lot of good tips in this webinar, as well as those that are open, you might find things that you haven't considered yet and want to think about as you're kind of fine-tuning your operations. Next poll question, please. So we also want to understand really what are your key challenges in getting ready to reopen. Here's just 5 particular ones. You can choose all that apply. So like we've talked about, getting your systems ready to operate, selecting which mitigation strategies to use of the myriad of options you have, and all these options are discussed in ASHRAE. The availability of the materials and equipment, like the lead times for filters, for instance, having monitoring in place already to be able to do this, or having the budget to implement these strategies, which I'm sure is challenging for most folks. So please answer multiple, and we'll wait a few seconds here. Great. Well, this is interesting results that, making sure the systems operate correctly. It seems like most people are realizing that that's a key component of this, goes hand in hand with selecting mitigation strategies. So we're going to get going to try to help answer those questions. Thanks for responding to the polls. Next slide, please. I'm going to quickly introduce, just in a broad brush, the Building Commissioning Association is an international nonprofit organization of commissioning professionals, and they're an industry resource on commissioning. We've been working, LBNL has been working with BCA in the Smart Energy Analytics campaign over the past 4 years. They're an organizing partner, supporting us in the campaign. And we reached out to them to share information about the commissioning perspective on reopening buildings with the Department of Energy's Better Buildings community. So I'm going to let Geremy and Jesse give their brief background and take it away.
How's it going? Hey, everybody. So I'm Geremy Wolff. I'm a regional director for our commissioning business here in the Pacific Northwest of McKinstry. Been in the commissioning industry pretty much my whole life. I think I actually, my work anniversary was yesterday, so I've got 22 years in the commissioning business, and I'm 46 years old, so that means I've been doing it for almost half of my life, I guess. But through my work with the BCA, I've been actively involved with BCA boards for probably the last 10 years or 10 or 12 years, and just really looking forward to sharing what information we've learned along the way. And I want to preface everything we're saying is, we are learning just as much as you guys are along the way, and new information comes out every day, and being prepared to adjust as we go.
And Jesse Sycuro, also with the board of directors on the Building Commissioning Association. Similar to Geremy, I've been working in critical operations and commissioning field for about 20 years now. And just to add to what Geremy said, both of us have worked in a wide variety of facilities and working on commissioning and best practices for operations in K through 12 schools and higher ed, municipalities, government, critical environments. It really runs the gamut. So looking forward to providing that perspective to this situation. And then both Geremy and I have been put in the throes of the COVID-19 response, both in how do we shut down buildings to support the initial response, and now the more involved process of reopening, and not just kind of undoing what we did from a shutdown, but looking at how do we respond to the latest research and findings, and take what we do know and apply that to best practices for HVAC operations. So looking forward to sharing what we know right now and what we've learned, and helping out with this journey with everyone here. So thanks for having us, and if you could go to the next slide. So I'll start here just with the map on the left-hand side, and I think the poll gave a good indication too of where we're at for reopening. I think we had a little bit over 80% of the participants here in some sort of stage of reopening, and either doing that in the near term, in the process of doing it or long down the plan of reopening and operating. When we look at the state map and where we're at, we're seeing the restrictions being lifted in a number of locations. That would be those blue boxes there, and in some cases being fully lifted in some places. We're in a really dynamic situation here. As Geremy mentioned, we're learning every day more and more about what does this pandemic mean and what are the risks that we're having to address from a building operations and engineering standpoint. And then from a policy standpoint, likewise, we're seeing policies continuing to shift and evolve as we learn more as well. So, in this dynamic situation, when we talk about how do we manage the risks of reopening, one of the approaches here that we're going to talk through is this hierarchy of controls from a safety perspective. If you're involved in safety planning at all, then you're likely familiar with this triangle. And it's really about looking at all the different ways that you can address risks that our team members and occupants have in the built environment. And it's really not about just looking at one approach to safety, but looking at everything as an overall plan and how you look at PPE as your in this case, face masks and social distancing would be more of an administrative control. And then looking at, what are your engineered controls that you can apply, and how can you apply cleaning practices to the approach. And ultimately, where you want to get to is if you can, eliminate the risk altogether. But I got that grayed out on purpose here because when we talk about reopening and coming back to work, we are going back from a place where we were able to self-isolate and eliminate that risk in the workplace to a situation where we do have people working in offices and working in proximity of each other. And even with the PPE and administrative controls we can put in there, there's still an element of risk. And so when we talk about our HVAC considerations and building operations, if you go to the next slide, what we're looking at from a hierarchy here is really focused on how do we modify our HVAC systems and operations as a method. And there's certainly a lot more discussion going on this hierarchy and how we're applying other practices to reduce our risks. But from an HVAC standpoint, we see this as a really key strategy overall to reducing risk. And one thing that I'll say, and we'll talk a lot more about this as we go through individual strategies, is that a lot of what we're talking about here is approaching HVAC operations in a standpoint of an abundance of caution. So again, I can't say this enough, we're continuing to learn, and there's more and more that we're understanding every day on how does our HVAC systems and our building operations impact the potential to reduce that risk. But a lot of what our recommendations are just that, what do we know and where can we apply additional cautions with systems and operations to provide that reduction in risk overall. Geremy, anything you'd want to add there?
No, I think just to double down on what I said earlier, it was funny when Jesse and I talked right before the webinar and said, was there any research that came out this morning that we should know about, that we should address in the webinar? So, very dynamic situation, and we're all learning this together, which is, a good thing and a bad thing all together. Right?
Yep, and I have no doubt that probably in our Q&A we'll have some study that's asked that came out in the last week that asks how does that apply to this situation though. So we're constantly working to keep up with the pace, and maybe I think that feeds right into the next slide if you don't mind going forward. So when we talk about what we do know and how are we coming up with recommendations right now, and where are we coming up with the strategies for this approach to abundance of caution. The ASHRAE references that Hannah had made that are available online are I think, a really good starting point. And the epidemic task force from ASHRAE, I think, puts in some great perspective too. I think they put it really well when they say that what we do know now is that there is a potential for exposure, that can be potentially linked to HVAC systems. And what we need to do is take what we know and apply that to our strategies for SARS-CoV-2 and continue to look at the research that's available. And when we talk about that, there's a couple studies here that I'll reference that I think are part of our strategies here. The first one on the left-hand side is related to a Chinese restaurant that saw an outbreak, and they were linked from the contact tracing back to airflow that was being pushed from a packaged unit across the room. And so I think it's a good example of how airflow in a space that increases that potential to spread the virus across a room is a potential link to HVAC factors. And we'll talk about airflows in the space and how we take this as part of our lessons learned. The study in the middle was a peer-reviewed paper that came out really early on from the University of Oregon and Berkeley University that I think puts into good context what we know from influenza, SARS, and other past research over the last decade, and then puts it in context of what we do know about the COVID virus and how it is potentially spread through contact surfaces, through airflow transmissions, and I think it looks at the filtration, potential for UV applications, and it doesn't come to firm conclusions, being a very early paper in the study, but it does make some great links and provides some good recommendations of what we should be looking at as we move forward. And then the last study I'll call out here that is a good reference point too is a call center in Korea that the Korean Centers for Disease Control published that really just emphasizes the importance of when we do have close proximity, long duration work environments, that there is an increase in transmission across that. The number of contact tracing that they did that linked coworkers really isolated it to a very specific area within the building, and they didn't see necessarily the same transmission rates in elevators or to multiple floors of this call center. It was really about the proximity of individuals for that duration in the space. So, again, the research is continually being developed. LBNL and the national labs and many other partners are looking at what is going on within the built environment and what information we can leverage. I'd say, take what we're providing with an initial snapshot and perspective on where we're looking at opportunities to reduce this risk, but stay current on the research that's available. Focus on the peer-reviewed papers that are being released, and what does that mean for our building operations. Okay, Jeremy, anything you want to add there?
Nope, I think you got it.
Yeah. So let's dive into the meat of it then and go to the next slide. So when we look at managing our HVAC response, I think there's a continuum here that we'll step through and get into each of the areas of recommendations here. But one perspective I'd like just to add here is when we think about how we step through our HVAC response and how we're looking at systems and operations, there's a way that we can walk through this that's really consistent with how we would do building commissioning and building optimization in general, which is, what are the lower cost, lower complexity items that are just part of our best practice approach to HVAC operations, and then stepping through in a really systematic way to increase the amount of effort and investment that we're doing, and putting that in the context of how does that link back to reducing that risk, and in particular for COVID at this point in time. So if just as an example, starting in the top left, maintaining your equipment, well, making sure that your ventilation systems are up, running, operating, and that you're addressing your deferred maintenance is a great starting point. And it's just a matter of best practice for how we operate buildings. And then going all the way through to where do we have at the end of this continuum, looking at alternative technologies and innovations that are more experimental and higher costs, higher potential impact, and leave some question marks, but are areas that we can evaluate through our planning process. And Jeremy, I'll let you take it from there.
Yeah, so let's go to the next slide. And so, yeah, I'd love to talk to you guys a little bit about, ventilation, systems, and, so the picture on the left, obviously kind of a typical air handling system that a lot of you have within your buildings. And to Jesse's point, we're looking at, from a commissioning provider standpoint, start at the basics and move to the complicated. And one of the biggest things you can do is go out and just make sure you're outside air, minimum, economizer, or whatever your setup happens to be, is actually working properly. It's not uncommon for us to go into an existing building commissioning scenario, working with a client, go up on a roof, look at an air handler, and find that the damper actuator is disconnected, or the jack shaft is bent and it doesn't open, or the intake is clogged with 5 years worth of cottonwood. If you live here in the Pacific Northwest, you know what that means. So you give the system the ability to actually bring the ventilation air in. And the approach that we are recommending to client, with people are, start with the minimum, because your system was designed around a ventilation rate, based on the occupancy in the building. What we are seeing, when we go in and talk with clients and go into buildings, is they're not at maximum occupancy, right? I'm in an office today that typically would have 400 people in it. There's probably 40 people in here today. And so, look at your your minimum ventilation, ensure that the system is operational and working as is intended, and that you are providing the design minimum airflow to the space. Now, if you look at a lot of the state reopening guides, ASHRAE's guidance, CDC guidance, they talk about maximizing ventilation, and dilution is the solution to pollution, right? That's the thing our engineering team is always talking to me about. And there's pros and cons to that. So you have to be careful, right? Your systems, depending on where you're at and what part of the country you're in, are designed for economizer operation, which would increase your ventilation air from the minimum position up to potentially 100%, based on outside air conditions. So you've got limited capacity within your heating and cooling systems. And so depending on the time of year, today I walked into the office, it was 68 degrees outside. We could run 100% outside air into the building, and everybody would be perfectly comfortable, wouldn't have any issues. As it if it creeps up to 85, 90 degrees today, that would be a problem, right? We would not be able to maintain space conditions. So really, before you make the leap and take the maximize ventilation means 100% outside air all the time, is look at what the constraints are within the space of the people that would be occupying it. What are the limits of the system? Depending on the type of building you're operating. If it's a office building, there might times we see service level agreements within leases that say the temperature will between X and Y, for a certain percentage of time. Research labs, hospitals, they have different constraints around what the temperature can be. So that's part of the consideration. The other thing is, we're in, I guess, depending on where you're at in the country, this is not going to go away, right? These changes that you're making are going to probably still need to be in effect as we move into winter. And so, if you make a change to increase that ventilation air, most systems are designed, they will sort of run into a heating capacity issue. And so, heating, what are you comfortable with within your space of, letting the temperature drop down? And these are not simple questions to answer. Typically you would need to bring in a commissioning provider or an engineer or something like that to help you define and calculate what the range can be, and what the limits are of the system. And then you, as an owner or an operator, will have to make a decision, working with your tenants or whatever the situation happens to be, of, what are we all comfortable with? And because you want to communicate this information to them as well, right? This is a way for you to instill confidence in them that you are doing everything you can do to minimize transmission within the space, so that if somebody needs to come in and work in the building, in the facility, they feel comfortable and that everything has been done that can be done. Another thing you see out there talks about humidity control, right? There's a fair amount of research on previous versions of SARS virus that show, maintaining humidity within the 40 to 60% range can reduce transmission. I won't get into the details of why. The challenge with that is most buildings within the US don't have humidification and dehumidification control or ability. We see a lot, depending on, again, where you're at in the country. West Coast, not much of anything, unless you're in a research lab or a hospital, a data center. We just kind of let it float. In the Midwest, we see a lot of dehumidification strategies, not necessarily humidification. And so, understanding what the limits of your system are, and that, for the majority of you, you're probably not going to be able to do anything about it. It's just going to be, what it is. Some of the other things we talked about is, demand control ventilation, which has been it's been an energy saving strategy that's been implemented across the country for quite some time. It's about deploying a system that can measure the ventilation requirement within the building and drive that minimum ventilation rate down as you have less occupants in the building. Obviously we just talked about increasing that, so recommendation around that is really to try to minimize that. And there's lots of different strategies of how that out there. The most common way it's done is through carbon dioxide sensors in the building. But understanding how that sequence is working, what can we do to temporarily override set points or make changes to the setup itself. Not really making, as we're doing, commissioning work for clients, we're not really making recommendations of going and making wholesale sequence of operation changes, like bringing in your control contractor, having them make modifications, because we're keeping our fingers crossed that, sometime in the not so distant future, we're going to be able to undo all this stuff and kind of go back to, business as usual. Other strategies are around flushing the spaces. A lot of buildings have a kind of a morning warm-up mode that would typically go into operation. The trick with the morning warm-up mode is they assume that there isn't any occupancy in the building, so they actually drive the outside air dampers closed. So looking at, can you override that? Obviously you wouldn't go into warm-up mode in the middle of summer, but is there a flush mode that you could deploy prior to occupants coming in and after they leave to just kind of exchange the air in the space? To determine how long you would need to do that, and for how much air you'd be bringing in. Again, that gets back to doing some calculations, right? So you get another volume of the space, what the capacity of the air handler is, how much of that is fresh air versus ventilation, return air. But definitely, I think it's a good idea to just kind of turn the air over in the space before the occupants come in and before and after they leave, just to eliminate anything that might be lingering.
Jeremy, just on that topic, I think what we're seeing is some clients starting to go to 24/7 hour operation of the HVAC systems, but generally I think where we're going for most buildings based on their systems is more of a 2 to 4 hour flush after hours. Does this sound about right?
Yeah, for sure. And I realize that everything that I am telling you, we're telling you to do here is going to have an impact on your energy bill, right? Yep. I mean, the trend in the industry for the last 15 years has been minimize to contain energy utility consumption, and these strategies, you're undoing a lot of those. That's the other reason for trying to make them a temporary override versus a permanent override, because 2 years from now you don't want to have a commissioning agent come out and tell you that you wasted tens of thousands of dollars, because you forgot to undo something. And then another point of this is just you're looking at where there's potentially bypasses in the system. So fair number of systems out there have got heat wheels, that you can if there's bypass air there, you're not containing that air or controlling that air. Filter racks is another place where it's very common for, and we'll talk about filters here in a little bit, but not uncommon when you're doing, we're doing a commissioning evaluation of an existing building to go in and find that all the gasketing material that was there on day one when the filter rack, when the air handler was brand new, was gone, or filters have kind of sucked in, or somebody's decided to change the size of the filters, the type of the filters throughout the years, and there's a nice 6-inch wide gap on one side of it where air is just going bypassing it. So doing kind of opening up these units, looking inside of them, seeing where there's potential issues between where the outside air is coming in and how it gets into the duct. That's a really important step that you could do along the way. Anything else to add there?
No, I think you got it there, Jeremy.
Cool. All right, let's go to the next slide. So talked a little bit about this, air distribution in one of Jesse's previous slides, but give you some examples of the types of, supplier diffusers that you would see in a typical commercial office building or a higher education or K-12 building. And the one that probably is, the one to pay attention to is the one on the left. So those the linear slot diffusers, and the difference between a linear slot diffuser and a four-way throw diffuser is, the four-way throw is designed, both of them are designed to hug air along the building, have it drop down, but you have less paths with a linear slot diffuser. They are typically installed in a building. Most common place we see them is along windows, and the idea behind it is to use the air to wash the window and prevent heat or cooling transmission back into the space, as an occupant would feel it. The research that was done on the restaurant in China showed, with the package unit, showed a high velocity or higher velocity of air moving across the space. And there's a reason that they've come up with 6 feet for social distancing. It's they've done some research that, hey, if it's contained within a droplet of moisture that comes out of your mouth when you cough, I'm not sure what the actual distance is. Somebody put an engineering safety factor on it and came up with 6, and said that most likely within 6 feet that moisture droplet is gonna fall and not be something that you can consume. When you get drafts within a building, you're kind of creating a little bit of a highway for those droplets, right? So looking at your building, walking through the spaces, understanding, do you have linear slot diffusers? If you do, potentially don't put people there. Like, move them away from them. If you've got a vanometer, you can actually do a pretty quick air velocity measurement. And if you have that, you'll realize that moving 2 or 3 feet away actually makes quite a bit of difference. Other places to take a look at in your building is, if your building has got historically pressure issues, right? So you've got a doorway that every time somebody opens the doorway, they feel a rush of air moving through it, or if you have space pressurization containment within the building, that's another thing to consider. The other thing, the pictures on the bottom, anybody that walks through buildings sees these things all the time, right? So you've got portable fans, portable heaters, portable AC units, dehumidifiers, humidifiers. Those all create air velocity within the space, and you can quickly defeat one of your safety measures of, okay, it's okay for you to come in the building and sit 6 feet apart. If you put something in there that can supercharge, or create that air highway for those droplets to move. So, the recommendation with this is walk your buildings, know your systems, look up. These are the types of things that when work orders come in, they're kind of low on the priority list. So, potentially go through your work order system, see if you've got anything that relates to these type of distribution issues, and look to see what you can do to address them. Anything else?
Yeah, Jeremy, I'd maybe just add that this is a great case for building air balancing too, and where you can, to your point, prioritize the airflow to that curtain wall, that linear diffuser versus the 4x4 throw in the space. But and we're always looking for excuses to get rid of the space heaters from an energy perspective. We finally have a really good reason from a safety standpoint. From an operations standpoint, I know working with a client recently, really trying to rush from an operation standpoint to be able to support the reoccupancy. One of the initial strategies was, let's bring in a bunch of temporary AC units because we couldn't get the central plant started up in time. And that's where we really flagged this as a potential concern and went away from that solution because of that laminar airflow that would push across the entire space and impacts the occupants. So just really look at airflow across the board on where are you pushing air and what impact does that have on more than anything that 6 foot social distance recommendation that we have right now.
Yeah, we've had a couple of clients talk about, we talked about the humidity being, people see humidity control being, something important, between ASHRAE, CDC guidance, and have a fair number of people have talked through with, should I go buy a portable humidifier or a portable dehumidifier and put it in the space? Same consideration. I mean, a portable humidifier is basically a tank that boils water and that goes up into the airstream, and a fan that just blows across it to put moisture into the space. So kind of defeating. I guess lesser of two evils. I would not recommend the portable humidifiers.
Yeah.
So we're gonna go to the next slide.
Yeah, so filtration, we've got a lot of detail on this slide, and we'll provide the deck following this presentation with links to even more detail if you want to dive into the specifics here. But to Geremy's point, a lot of the discussion right now is on figure 1, which is, are we talking about transmission of COVID by droplets or by aerosols? And it's where a lot of the research focus is in the built environment to really understand what is the risk of COVID to HVAC systems and potential spread through ductwork. We do know that there is an element of an aerosolization of COVID, and as well as the droplet. A lot of the existing research right now is pointing to transmission between people by droplets. So that's where a lot of our current focus and recommendations are. But knowing that there could be a risk from aerosols, and again, approaching this from that abundance of caution standpoint, we look at filtration as a potential means of reducing risk. And so that's where you're going to see some of these other recommendations coming in for how you address filtration within your building. If I go to the bottom left there on figure 2, look at the MERV ratings and the efficiency of that filter to remove particulate matter based on the size. The red line is your MERV 13, which you see a really high efficacy for removing small particulates and a relatively higher efficacy across the different sizes of particulate matter across the board. And so generally what you're going to see in recommendations is where you should be using MERV 13 filters. But there's a lot of consideration there on the system capabilities. So is the filter assembly sized to be able to take that? Even more importantly, is your system sized and able to continue to move airflow appropriately with a MERV 13 filter? If it wasn't originally designed for that, you're going to have some really big challenges trying to increase your filtration. But as an abundance of caution and general recommendation, that's where your MERV 13 recommendation is coming from, is how it's able to remove particulate matter. And there is a number of pre-existing research studies on influenza, SARS, and other viruses that do indicate, how the MERV 13 is an appropriate matter. We'll certainly be able to be a lot more specific in that recommendation and potential investments in increasing filtration once we know more about the transmissibility of COVID-19 via aerosols. But outside of the MERV rating of what filter you're using in your system, the right-hand side of this graph does bring up a couple really good points on, it doesn't matter what filter you're using, you should be really looking at how often you're replacing that filter and how that filter is functioning within the system. So the top right is looking at a MERV 13 filter study that looked at how effective was it based on the age of the filter. The very top line in this graph showing its efficiency to remove particulate matter for an unused filter. And then as you step through this, the age of the filter is increasing and the efficiency of that filter goes down. So if you look at the smallest particulate size, a MERV 13 filter is 75% efficient at removing that particulate matter when it's brand new. And as quickly as within 7 weeks, and certainly within 13 weeks, you start dropping below 50% efficiency. So you're going to see filters and their ability to remove particulate matter going down in their efficiency significantly over time. So to look at how do you address that from a risk standpoint, really looking at what's your filter replacement schedules and how do you adjust those and increase that frequency. Knowing there is a cost impact certainly for your operations, but looking at how do you balance that with the current recommendations and risks that you have with COVID-19. The bottom right, figure 4, is just a general best practice. Airflow through a system is always going to go through the path of least resistance. So if you've got gaps on the side of your filter assemblies, if you have holes in your filter, obviously, you're going to see a large amount of bypass airflow. And I think it's pretty obvious, but there's some graph and research that shows just how bad and poorly your filter efficiency goes down when you start seeing holes in and bypass routes to airflow from your filter. So just from a maintenance practice, look at how is your system currently performing. Do you have gaps? Can you tape those as a temporary repair if you've got gaps around your assemblies? And certainly replacing any filters that have deficiencies in them and removing those bypass airflows where you can. So again, I just want to reiterate, a lot of this will really come down to what do we learn on the aerosol transmissions and how does COVID-19 potentially get transmitted through ductwork. But in the meantime, really thinking about what is your filter approach and strategies and how do you address the risks that we know right now.
Yeah, I think the other thing, yeah, a couple of things. We've fielded a lot of questions over the last couple of months about HEPA filtration. Should I put HEPA filters in? So the answer is no. Just leave it at that. So an interesting article from in the New York, I think it was the New York Times a couple of weeks ago, where the mayor of New York had put out a statement saying, "Hey, we want to encourage," or I can't remember if they're encouraging or mandating all facilities that we open to go to high efficiency filters. Through the course of that article, the person that wrote the article converted high efficiency filters to HEPA filters. Big difference between a HEPA filter that you would use in a clean room or an OR and a MER 13 filter. A MER 13 filter would be considered a high efficiency filter. The other challenge that we are seeing around MER 13 filters right now is just availability. So here in the Pacific Northwest, we do a lot of service and maintenance, and so we buy a lot of filters. We are seeing about an 8-week lead time today if we were to go order a set of filters. So I saw at the beginning of the poll, there are a lot of you that are in process or in some form of putting your plan together. So thinking about the timing of that, if this is something you really want to go explore, you might want to prioritize it because you might not have the product available to actually go into the building for a couple of months.
Yep. So hand sanitizers, masks, plexiglass barriers, and now you can add filters to the list of.
Exactly.
So,
exactly. Yep. You can't buy them all at Home Depot. So.
All right. I think we can go to the next slide here.
So the other thing, spending a fair amount of time talking, about recently has been kind of alternate technologies. And if you on the call are like me, your inbox is bombarded every day with emails that talk about COVID-19, technologies, approaches, things that you can use to kill the virus. And so wanted to address a couple of them today. One thing to be aware of is, COVID-19 is a relatively new virus. There isn't a lot of research out there, and the red flag for me is when I see somebody send me something that says this is guaranteed to kill COVID-19. I usually discard it. The reality of it is none of these people that manufacture this technologies actually have the virus to test against. No government's giving it to them. They can test against similar type viruses, but there is no 100% guarantee. But the two we hear most about are some sort of ionization and UV sanitizers. So if you've been in a restaurant, a lot of times you see the wall-mounted UV sanitizers over a wash sink or a prep station. Very localized, small radius ability to use sanitizers. So I've got a couple pictures of a couple different options that are out there. One is a direct installation within an air handler. So the picture on the left is actually, you can see the UVC bulbs are in the airstream downstream of the filters. A lot of research still being done on how effective this actually is. I guess from what I've been able to ascertain in talking with actually many of the manufacturers, is it's a function of time and exposure. UVC is pretty bad stuff, right? It'll burn your skin if you go stand in front of it, and it's not something you'd want to put into a space where people would be actually occupying it. But I don't know. The jury is still out for me, I guess, on whether or not this is a technology that I would rush out to do. It's a pretty, the cost is not inexpensive. There's lots of things you can do from a low cost, no cost, just due diligence that I think would have just as much of an impact on your environment. And the studies are still out there as to whether or not the ability of a return air grill to suck up a droplet, pass it all the way up to the air handler, through the fan, through the filters, through the coils, back down the supply air duct and into the space. And is there actually a viable transmission that can happen to that? There's nothing that shows that can happen. There's some studies that show there's some pieces of the virus that have been found downstream in the duct of these, but nothing that indicates whether it's a live viable virus component that could actually infect somebody. The other thing we're seeing a fair amount of is they call it a retrofit troffer. So you think of your 2x4 light fixture that would be in a standard drop-in ceiling. This is a retrofit, kind of a direct retrofit that could go into the ceiling. It's got kind of the UV or the LED lights, and there's actually a fan assembly with the UV sanitizer built into the backside of it. So it's sucking air in, sanitizing the air, dropping it back down. Again, pretty low velocity fan. Not gonna, if you got a big volume of space, a big open concept design, would take a fair amount of these devices to have a big impact on the space, and pretty costly. Like both of these, we're talking, kind of capital investments that I'm not sure anybody's ready to take on, considering that it's still a little bit not sure how effective it is. The other one we hear quite a bit about
Geremy,
is
sorry to cut you short, but I'm just getting an indication from Hannah that we got some good questions coming along, and we want to make sure we get some time on that.
We'll talk about
how much we love ionization, but we'll see. If it comes.
Okay, I'll skip over ionizers, but other than same story with ionizers as UV, right?
Yep. So if we can go to the next slide, and we'll hit this last slide, a couple slides quickly here, but just high level here on water distribution systems. We shut down buildings very quickly in a lot of cases, and in some cases that shutdown has really provided a good or bad, depending on your perspective, environment for the potential for biofilms, and in particular Legionella. So just as you're reopening, this is outside of the HVAC discussions we're having, but just want to make sure we note this, that look at best practices, look at resources available. I'd point people to CDC's recommendations for how you diagram out your risks within your water system, and then also how you look at water management plans. And they've got a good reference for an example on how do you restore and come back to operations and address those risks. Okay. So we'll kind of go over that quickly. You go to the next slide, last one here, before we get to some Q&A. So, as Hannah mentioned, as part of the approach here, it's about evaluating where you're at today, implementing a plan for reopening, and then sustaining those results is just as important. I think from two areas that we would recommend that you look at this is ongoing commissioning. So how do you look at your performance metrics and the things that you've implemented related to your filter performance, and looking at differential pressure as an example of how you monitor that, looking at your outside airflows, your relative humidity control. Build specific key performance indicators that indicate that your strategies are working and that they're continuing to work within the space. And then from an ongoing commissioning standpoint, if you have an energy management information system available and in place, leveraging that and adjusting your strategies for fault detection to give you notifications and proactive means of monitoring the performance of your COVID strategies for reopening. If you don't have that technology in place, certainly look at the potential benefits of an investment along those lines to give you that tool set and enable that. But just as much so, from a maintenance and from an operation standpoint, you can implement processes and checks across your team to keep an eye on that performance and update your maintenance plans appropriately so that you're maintaining that performance going forward. Just in the interest of time, Geremy, I know you touched on seasonal changes. It's just emphasizing for everyone that we're implementing all these changes right now in July. At some point, we're going to see a change in weather. We're going to see the strategies that we're implementing now being really challenged from a system standpoint, and how you can maintain that throughout the seasons that we'll see in fall and winter, and readdressing your strategies based on your system limitations with weather and climate changes. So I think, kind of wrapping that up quickly, but Hannah, I think you mentioned that there's some good questions coming in. So let's maybe pivot, and you can go to the next slide, and we can just address questions that we have now.
Great, thanks, Jesse. So I'm going to just jump right in here. This was a question a little earlier on about the control sequences on how you're controlling your outside air. So has ASHRAE or anyone else suggested a control sequence to maximize outside air while controlling discharge air temperature, such as a trim and respond reset of outside air damper position or airflow set point to maintain cooling or heating capacity? You talked about needing to be aware of meeting your loads at the same time as maximizing outside air. So can you talk about if there's any published control sequences out there or that would help users?
Yeah, I mean, I haven't seen a specific sequence of operations published, but I think that's really hard from the number of different systems and designs that are out there for there to be a one-size-fit-all sequence recommendation. I think, what I've seen so far is, a recommendation to turn off demand control ventilation from a sequence standpoint and maximize your outside air as much as possible. The preference going to 100% outside air if you can with your system capabilities. And if you're going to a full-blown 100% outside air, then you don't really need the details of a trim and respond type approach. It's just on or off type of a sequence on that.
And I think there's some, and back to, there's some, you could use some resources to help you do kind of, you think about your latent heating and cooling loads are going to change with your occupancy as well, right? They're designed around a building that's going to have a maximum occupancy of 100 people. You design around 80, so you got like 20% diversity in there. If you only have 30 people in the building, or if you're limiting capacity to 50%, so it's 40% in the building, that actually adds another dynamic to what the system can and can't do.
Great, thanks so much. Next question, you mentioned not putting people under a linear slot diffuser, but don't linears push air to the floor where we might want it?
I think it was more about the air velocity, right? So again, got to be pretty general with our responses. Depending on how high is the ceiling, how is the throw actually set up on it. There's a lot of variables there. Just something to be aware of is that typically you have higher velocity air movement around a linear slot diffuser, and so you do a smoke test, use a manometer to figure out where the velocities are at, and I think the recommendations we have seen has been to move people out of any high velocity areas.
Yeah, a lot of it's space planning too, and just thinking about where are your occupants at any given time. And if you think about that 6-foot radius, that is the recommendation right there. If you look at how a person is positioned in a space and where they're breathing, what you really want to do is just maximize your airflow strategies so that you're not pushing that air from one person across a room. That's the bottom line.
Great, thanks. On to filters. During the discussion about filtration, you mentioned that filters become less efficient as they load up. This seems to contradict our organization's understanding that filters become more efficient as they load. So can you explain that?
Yeah, when you're able to look at the presentation in detail, what you'll see is that efficiency over time actually gets maintained, and to your point, can go up with a larger particulate matter. But where you see that breakdown and you see the efficiency going down is on the very small particulate size. The deck that's going to be sent out does have a link to a presentation from the University of Toronto that goes into about an hour-long discussion on filters and research that they've been doing over the years on efficiencies, and that's where that was referenced, and recommend that if you do want to dive into more detail on that. But the efficiency decrease is really on the very small particle size, which is what we're talking about with COVID-19 aerosols potentially.
Interesting. Great, thanks for those details. That's very helpful. What would be your recommendations for COVID solutions to buildings that do not have forced air systems, like historical sites, for example? That may be a very big question, but if we could give a broad brush answer.
Yeah. Everybody take it one, Jesse? Or I can start. Right? So we actually have a couple of clients we're working with that have those type of situations, and higher ed is very common, right? And then they've got buildings on campus that are 80 years old, and the only thing you can do is open windows. It's about getting getting as much ventilation, fresh air into the space as you can. It's not some of the questions you have. Hey, put a box fan in the doorway. Push air through the space and try to blow from one end of the building to the other. But the concern with that is you're creating that velocity of air, which can move the virus farther than you want, than the 6-foot rule if you're running with that. So there aren't a lot of great strategies other than if you've got upper windows, open the windows. I don't know if you got anything else, Jesse.
No, it's there is no one size fit all, and there's no perfect solution here for any facility. So just think about it from a risk standpoint, and if you do have no option and you're stuck with a certain situation and design consideration, then look at other strategies that you have. If you were looking at social distancing of 6 feet, maybe you have to increase that in your space planning. If you were looking at masks as an option for PPE, maybe you need to look more aggressively at that option too. So if you can address it from an HVAC standpoint, you have to look even more so at the other strategies that you're implementing across the board.
Thanks. What is your opinion on point of view standalone filtration in higher occupancy spaces when we're not able to increase outdoor air or in-unit filtration?
Yeah, I think maybe I'll start there, Jeremy. One piece of advice there is, again, the laminar airflow. So those point filtration solutions need to have airflow going through them, and that air needs to go somewhere. So are you able to implement a solution like that and still not see an increase in that turbulence of air throughout the space? There's a cost to that, especially on the more effective solutions on the filtration. So I would, look at that strategy as a potential, balance that with where is that going to support you from a risk standpoint. And I would generally, I think, look more at where do we see the research going for aerosolization and the effectiveness of those filters to really reduce that risk in spaces before making a solid recommendation.
Mm-hmm.
Yeah, so the only place we've actually seen that deployed has been in the hospital environment, and they're using it primarily to create negative pressure spaces. So, a portable HEPA filter and, pulling air into the room and then throwing it out through a window or some kind of a temporary, outlet through the wall. So
yeah,
I echo that concern of the velocity.
Okay, great. Do you have any recommendations on PPE requirements as we are working in airstreams or changing filters?
Yeah, the recommendation before COVID-19 was use an N95 mask if you're dealing with filters. They're removing a lot of nasty dust and particles from the airflow. That's their job. And you should be bagging and packaging filters as a risk for anyone that's maintaining those systems. So N95 mask has always been the recommendation and would continue at this point in time too. Only other addition to that is, use gloves and treat it as a potential risk for people that are maintaining that system for COVID-19. But how we would address it previous to COVID-19 is really similar to how we would do it now. Jeremy, any thoughts on that from service standpoint?
Yeah, no, same.
Yep.
Okay, we're going to get one more question in because I want to make sure we cover the upcoming research by the labs very briefly. So someone would like you had to skip ionization, but now they want to know what you think of bipolar ionization and the new research being referenced on related to COVID-19.
Yeah, I can take that one. It's similar to UVC, right? I think it's it's still a bit of an unproven technology. Yes, it is an ionizer, and yes, the way the technology works, it creates an unstable oxygen molecule which attacks something that because it wants to get rid of that extra positive or negative charge. It is an effective disinfectant. It's been, ionizers not new. There are side effects associated with it. Haven't been used. I think haven't been tested, or I haven't seen a lot of research at scale of what the downstream side effects could be. Both of those technologies, I think when I talk with people, I equate it to using a sledgehammer to try to drive in a finishing nail, right? There is yes, they will most likely have something kill the virus, but the fact that we haven't seen any research that shows that the virus can actually make it to the air handler in a viable state and back down into the space, which is where you'd want to install that type of technology. I think there's a lot of things you could do for less cost that would probably be more effective based on the information that we have right now.
Yeah, and I would just add that there's certainly potential to affect the risks. So that's the one area that we want to keep a really close eye on in these technologies, including ionization. A lot of the research that I'm seeing seems to be manufacturers partnering with research institutions to come up with the data and the findings, really looking, and I think this leads well into where you're going to go, Hannah, is what are the national labs doing on these topics, and what are independent research studies from universities that we'll be keeping an eye on. Where do they point us to with these alternative technologies as well?
Yeah, great. So next slide, please. I'll just briefly mention this National Lab Consortium. We do have a lot more questions we didn't get to, and maybe in a future webinar we can aggregate those and figure out what that webinar looks like. But I'll just briefly say a group of 6 national labs recently come together to work quickly on important research around how the coronavirus responds to different environmental conditions and how that translates to risk and mitigation strategies. So they're looking to fill gaps in understanding and keep an eye out for in the next 2 to 6 months for some findings coming from this, and that definitely will be disseminated. Next slide, please. The next thing I wanted to just mention is another project we're starting on to collect building readiness plans for pandemic operations. So we're collecting these, we're going to anonymize them and share broadly through Better Buildings. So I want to, I won't have time to do this next poll, but I want you to go to the next slide, please. If you're interested in sharing your plans with us, and at any state they are, please email me, and we'll keep everything confidential, but it really helps us to share what other people are doing and kind of aggregate best practices. Next slide. You know, Geremy and Jesse have done a great job of giving us lots of things to think about and good details on how to reopen buildings. There's a lot of support you may need from commissioning providers. Here's some links to find providers in your area through 3 different groups. Next slide. And finally, I'll put in a little plug for the Better Buildings Alliance EMIS tech team. You might be interested in our ongoing discussions on monitoring platforms and energy management information systems. So if you'd like to join that, please email Claire Curtin. Last slide, please. Here's our contact information. I'd like to, first of all, thank Geremy and Jesse for really excellent work in pulling this together on short notice. We really appreciate what you've done. And yeah, please contact me if you have some ideas for future webinars. We're here to help pull together the pieces and communicate building reopening strategies amongst the Better Building partners. So with that, thank you so much for attending the webinar today.
Great,
Thanks,
thank
everybody.
you. Thanks for having us.